well, when we define the objects, we also put them a relationship between them, like we do in real life. Like I have a father, and I'm genetically very similar to my father. Like my face or my even abilities, talents, and are also coming, partially is coming from that. We also applied this to the classes. Like when we create let's say that I'm creating an e-commerce platform in which I will sell many items. So for that one, I might need to create separate classes for each of them. Like I'm selling a book, I need a book class, and also a computer class, smartwatch class, and so on and so. So this will, and then, well, let's say that I'm selling 10,000 items, then I need 10,000 classes. This might be very problematic if you don't apply inheritance. Why is that? Well, let's say that all of them has an ID, all of them has a price, all of them has a name. And then if I want to, so what should I do is I need to copy paste everything, like string IDs, string names, and so in 10,000 times, in all of them. And if I want to change one of it, like let's say, okay, integer string, ID is a string, let's make it integer. Then I need to make those all changes in 10,000 places. So that is like I might do many mistakes, many copy paste errors, and so on and so. So in order to not to have it, what we are doing is we say that, okay, let's create a class which is, let's say, product. So because eventually book is a product, and computer is a product, smartwatch is a product, and all products have a name, ID, and a price. So, and then I build this relationship which I say, I will call the super class, the parent class, which is in our story, it is in this product class. And then all of them are inheriting this product class. What will happen is that then, what is the main feature of this is, I will use this name interchangeably, like super class, parent class, the base class, for the product part, and also the child class, derived class, or this subclass for the class that like this book, product, and smartwatch, and so on. And the good thing here is that the subclasses has access to all non-private attributes and the methods of their parent class. So which means that I don't need to redefine ID, name, price for all the items that I'm selling it. I just need to define it in one class, and then whatever I do change that, it will affect all of them. So this is the main idea of inheritance. And here is the syntax, like when we are defining a class, we say the subclass, and then we say extends superclass. So we say that, okay, this smartwatch extends product, book extends product. We build this relationship between those classes by using this keyword. And then I'm just making a very quick recap of the last lecture. This can be in many different examples, like student, I can say graduate student, undergraduate student. I can create a shape class and then say circle, triangle, rectangle classes. Employee class, and then faculty is an employee, staff is also an employee. Or I can have a bank account and then checking account and a saving account. So actually this is something that we also see in real life. Many items are actually very similar. They share many common points. We would like to use this feature in our programming. And here is one example. This is the class diagram that shows also the inheritance relationship between classes. Let's say that we have this equipment class in which it has this name, manufacturer, weight, and cost attributes. And then we say that, okay, these pump, heat exchanger, and tank, they also extend this equipment class. And then for this pump, we also have these 3 different versions. And for the tank, we have these 3 different versions. All of them, we also see some attributes. Why is that? Like, let's say I'm similar to my father, but I'm not exactly like my father. I might have some different attributes, different functions. So I can also, a child class can also add some more attributes to its class, and also some functions. Here is the same thing. And then when we are defining this pump class or this, let's say, floating roof tank class, which is here, I look at it, okay, it has only two attributes like diameter and height. But when I'm saying that, okay, I can define these attributes like name, manufacturer, weight, cost, volume, pressure, diameter, and height. Okay, where does this all come? Well, because I see only two of them, and okay, these two exist here. But where is this pressure? Where pressure comes from its parent class, which is tank. Also, the volume also comes from this tank class. How about this cost, weight, manufacturer, name? Well, because it comes also from the equipment class. So I don't need to redefine all these attributes. I just defined what is the difference, but all the other comes from the previous parent class, from the parent class. So this is one example for that. And here one more part. This arrow sign will means that generalization. So basically, if we have this employee class, and then this is how we show it in a class diagram. We are saying that part-time employee extends employee, full-time employee extends employee, so that we know that when we say that, okay, full-time employee has also access to non-private attributes and functions of this employee class. And we were at this slide. So the functions and the methods are inherited. So let me demonstrate it for you actually. So I will go from, let's just do one more example. So I will create another class. Let's say that we have this product class. Oh, this already exists. Okay, let's open that then. Do we have it really? Wow, okay. Oh, this is like a quiz question. Okay. Okay, we have this product class in which we have this, let's say that not a string, of course, not an integer. Let's say we have string name and we have some price, maybe, for that one. And then I want to introduce another item. Let's say book class. And then in this one, what I will say is extends product. Okay. That's it. So what does it mean to have access to non-private methods or attributes in a function, let's say in an M function that I defined for a book object? Even though I didn't define any attribute, as you can see here, if I say name, it won't make it a problem. The reason is that because in the product function I have a product class, I have already this name attribute. And I can also have access to this price one, so I can also use that one. And I can also, like, if I would like to define its constructor, then I can just say, maybe I would like to have this set the name and the price. So this dot name is equal to name, and this dot price is equal to price. So even though I didn't define it, it is already there. I can also add some more that I need, like maybe I would like to say in a string I need a title. That is, so then I can introduce my own attributes for that one. And if there's any function here, like public calculate void calculate shipping cost, for instance. So whatever it does, its content is not important for us for now. but I can also access it here, and I can even run it like here. I don't, because I'm assuming that this class is already defined here. So this is what inheritance allows us to do it. I can access all the functions, non-private functions and attributes here, and then use them as here. But now, this, we were at this slide, so I will maybe make it a little bit one deeper recap. So these methods are inherited. I can use them, but not the constructors. So what does it mean? In a product class, I have I can also define its own constructor. I'll just put here a message just to show that, okay, this is running, okay? Product constructor is running. Then in my book class, is there any also this product constructor? No, I cannot inherit that. I cannot use it. But the thing is, now let's create this book class, okay? This book class here. So what I will do, I will create an instance of it. So I will go to my main method, and then I will create a new book class. And it takes two arguments. One of them was its name, and the other one was its price. I'll just run this one. Okay, I just created one instance, and then I will run my code. And then here is the output. It says product constructor is running. So now this is kind of interesting part. Now I created on this book object. When I go this is its input. But for some reason, this product function is run. This constructor is run. So how is this possible? Well, the main idea is that, now I will make one analogy from the real life. Like, in order to be, for me, if I was born, first my father should be born. Otherwise, I might not be I shouldn't be in this world. So this is the main idea. Like, if you want to create a book, you should first have a product. But this doesn't mean that we are creating a product instance. We are just making the required, the needed initialization actually. This is the main idea. Like, I want to create a book object, but for that one, maybe there are some special things that I need to do for a product, maybe some unique ID assignment and so on. Then that's why its product is constructor is called. Then you can say, okay, how is that? Like, because in this code, I just have these two lines. There's nothing that calls this product function, product constructor. Well, the thing is, if you don't type it, Java puts this code for you. That's super, and this one. Like, if you type it by yourself, Java does not do it. But if you don't do it, it puts it for you. So what does the super means? Super, if you remember from the naming in the very first section, I said that this is super class, the parent class. So when we are talking about inheritance relationship, whenever we say super, it means the parent class. So your father is always super. Okay, so here's the Superman, and whenever I say super, it means the parent class. Okay. And what does the super mean? It means that call the constructor of the product class. And there are some rules that we have to follow. What is this? Like, okay, I want to call the product class, okay, but not the one that takes no parameter. This is the default one, because I have maybe I have one more product object constructor, which takes the name and also the price as a parameter, and it sets them accordingly. Okay, I want to call this one, not this one. Okay, so for that one, what I should do is, okay, I will say, if I put this here, then Java will understand that, okay, I'm calling the constructor of the parent class, which takes one string and one integer, or one float, sorry. So that then it will basically, in order to show that, okay, this is the one that runs, I would like to put here one message, constructor with parameters is running, okay, just to see that it is running. And I'll go back to book class object. Now what I need to do is, now first I'll show that this is running. So I'll go to main method and then I will run it again. Now it says product constructor with parameters is running. So now that one is called, not the other one. But now going back to this one, do I really need these codes now? I don't need them. The reason is that in this super function, I already set it to name and to price. So now I don't need it. That's why I can just delete them and the result will not change. But what I can do is, maybe I would like to say set the default one to title to default value. Maybe, like whatever you would like to do, but because this doesn't belong to the parent class, title it belongs to the book class only. And there's one rule that we have to follow, which is this super line. Can I put it as a second line of the constructor? No. Definitely, there's no any other possible that it should be always the first line. So again, because your father should be born before yourself. So this is the main idea, that I cannot do anything for the book class before I do necessary things for the parent class. So this should be always at the in the first line. All right. Do you have any questions so far? Right. Then let's give 1 minute break for attendance. Then we'll continue.